Hello everyone, today we're going to talk about the implementation of the egg dropping problem. So we will talk about both the recursive and dynamic programming approach to solve the egg dropping problem. And we will also talk about why the dynamic programming approach is better than the recursive one. So let's first talk about the recursive approach. So here we have the egg dropping class. So in the main method, we specify the number of eggs with n and the number of floors with m. So here we are trying to solve the egg dropping problem with 2 eggs and 11 floors. So we call the egg drop function, which is a recursive function. So in the egg drop function, we first handle the base cases. So if the value of m is 1 or it's 0, we simply return m. And similarly, if we have only one egg, so in that case, the maximum number of attempts will be equal to the number of floors. So that's why we return m. Now, after checking for the base cases, we will try dropping the egg from each floor, starting from the first floor till the last floor. Now, when we drop an egg from floor X, either it will break. So when it breaks, we will have n minus 1 eggs remaining, and we still have to check x minus 1 floors. And if it doesn't break, we will have n eggs remaining, and we still have to check m minus x floors. And we take the maximum out of these two values because we are trying to minimize the number of attempts for the worst case. And another important thing is when we drop an egg from floor X, we are making an attempt. That's why when we return from this function, we add 1 to the minimum drops. So we return minimum drops plus 1. Now let's execute the code and see the result. So here we have added a print statement so that we can log the call that was made to egg drop function. Now let's execute the code. So the minimum number of drops in worst case with 2 eggs and 11 floors is 5. Now we can see all the calls that were made to egg drop function. Now if we copy one of these calls and search for it, we will see that there are many occurrences, which means we are solving the same subproblem again and again, which is very inefficient. So that's the problem with the recursive approach. It solves the same subproblem again and again. Now, rather than solving the same subproblem again and again, we can store the result of the subproblem in an array. So next time when we need the result of the subproblem, we don't need to recalculate it again. We can directly get it from the array, which will be very efficient. Now with dynamic programming, we can do that. So let's see the dynamic programming approach. Now in the dynamic programming approach, we will have a 2D array called dp table, where dp table ij will represent minimum number of attempts needed for I eggs and j floors. And since the array index starts with 0, the size of the dp table will be n plus 1 and m plus 1. And then we fill the initial values in the dp table. So when we drop the egg from first floor, it will always take us only one attempt. So regardless of the number of eggs we have, it will always take us only one attempt. Similarly, when we drop the egg from 0 floor, it will take us 0 attempt. So regardless of the number of eggs we have, for this case, the number of attempts will be 0. Similarly, when we have only one egg, the number of attempts will be equal to number of floors. That's why dp table 1j is equal to j, which denotes the number of floors. Now after filling the initial values, we start with 2 eggs and 2 floors, and we keep filling the values in the dp table. So when we drop an egg from floor X, it will either break or it will not break. So we take the maximum values out of these two values, and since we have dropped an egg from floor X, we add 1 to this value, and finally we return dp table nm, which denotes the minimum number of attempts required in the worst case with n eggs and m floors. So let's run the code and see the result. So the minimum number of attempts in worst case with 2 eggs and 100 floors is 14. Now let's change the number of eggs to 3. So minimum number of attempts in worst case with 3 eggs and 100 floors is 9. Now you can get the code for this problem from here.